Greeting to one and all. This is ARKAJIT Datta, and in this video, I'll be talking about my project, which is development and analysis of malwares. And this project I have done under the subject of malware analysis, winter semester 2021. And specifically, we'll be talking about the review too. So, coming to the abstract, the term malware stands for malicious software. It is a kind of program installed in the system without the knowledge of its owner. These malicious softwares are being installed by the third party to steal, damage, corrupt, or some any important personal data of the user. So sometimes people just have intentions to play pranks and disturb the security integrity of an individual. So, in this project, as the name suggests, development and analysis of malwares, I have tried making two malware. The first one will be a keylogger. So, the keylogger will be basically tracking the keystrokes, and the keystrokes will be saved under a txt file such that we can store it and analyze it further. So basically, if an attacker installs the keylogger in the victim's computer, then whenever the victim is typing anything, each and every word will be separately saved inside the txt file, so that whenever the attacker comes and opens the txt file, then he or she can easily find like what exactly the victim has written. Next, we'll be trying to build a trojan. So we'll be basically having two trojans, and this will be done using msf vnorm. And msf vnorm is a very useful program which can be found easily under kali linux. And in this, we'll try to, after building the Trojan, we'll try to run analysis like malware analysis using virus total, so that we can find whether any antivirus software is able to detect our Trojan or not. Or again, the next thing will be using any.run, as any.run is the best way to do the dynamic analysis, to do the network analysis. It can easily track any callback, reverse shell, anything. So we'll be even seeing that um, the Trojan analysis under any run, and try to get the report and try to analyze that. So now we'll be first looking to our keylogger, for which I'll be switching to my PyCharm ID. Basically, the keylogger has been coded in Python. So let me switch to the Python library, PyCharm. So now we are on our PyCharm screen, PyCharm ID, and this is the code. So basically, here I have used the library called PyInput. Basically, PyInput is a Python library. It helps to detect the keystrokes. Any keystrokes, it can detect it and it can listen it. So basically, if I've been typing anything on my keyboard, this library can easily like detect the keystroke, and then we can do whatever we want with that. So let me try to explain the code a bit. So we have some global variables called count, and I have initialized that to 0. Keys, this is a list basically, and there is a function called on press key. So basically, what is happening whenever I'm pressing any key using the PyInput, I can easily I'm doing keys dot append key. Basically, in the list keys, I'm appending the keystroke. Basically, it is storing the character. Probably I have pressed a, it will be storing that a, and next it will just incrementing the count. After that, incrementing the count, it is even printing. So this is basically printing the keystroke which I have made. And we can even see that when I'll be demonstrating running the code, we can see that whenever I'm pressing anything, it will be shown in the input, in the output screen. Now, whenever the count crosses 20, like I have pressed 20 times, I have done 20 keystrokes. this count will be reinitialized to 0, and my all the keys inside the key list will be updated in a text file, because key list will be made temporarily in the RAM, but the text file will be storing it for it will be storing it in the hard drive. So I can just keep it as long as I want, right? So I can just keep it anywhere in the hard drive. I can just keep it for 1 year and then take out, it will be there. But after I stop the program, if somehow the program stops, the key list will be terminated, it won't be existing. So it is very important that we update the keystrokes in a text file. After updating the keystrokes, I am even resetting the keys. Basically, the key list is being emptied such that the new keys can come up. It is a good way of a coding practice, such that we can again we are just freeing up our space, because if we are just storing the things up, we'll be just expiring our RAM. Next, we'll be coming to the def write file, which basically opens a key log text. This is a text file, and as we can see under the project, there is a text file over here. Also, this text file will be basically storing the characters we are pressing, the keystrokes which we are doing. The characters will be stored under this text file. Now, some modifications I have done over here. Whenever there will be a space, whenever the program is identifying any space or enter anything, at that time it will be going to the new line, so that I can just separate each and every word. Because I want to analyze, a malware analyst or a attacker just want to analyze the keylogger. So after getting the words or keywords, he or she will be trying to find some useful information. So it is a good practice if we can separate out the words so that it's easy for analysis. Then if any keys is fine, then it will be just writing it to the file. And on release, basically when we'll be pressing escape button, at that time uh, the code will be terminated. And this is a basically infinite loop kind of thing. Basically it will be continuously listening. It is also coming from the PyInput library. It will be continuously listening to our keyboard, continuously tracking our keystrokes. So now it's a time to run the code and see how it performs. So I'll be running the code. Now I have run the code. I'll be trying to type something. Let me type my name first, Arkajit Datta. And as you can see, all the things are being printed over here. ARKAJIT DATTA. Let me write something. Is a student of malware analysis class. So I have written these things, and all those things have been uh, stored over here. So I have written these things, and the output, we can see all the keystrokes, all the characters are being printed. Now I'll be stopping the program. After stopping the program is being now terminated. Now we'll be going to the keylog text file, and we can see Arkajit Datta is a student of malware. So all the words have been printed, all the words have been stored. So this is the use of a keylogger. Now we can install a keylogger directly to a victim's computer by using some pen drive or something. But it will be very good if we can just do it in a network so that the victim would be able to know that. So for that, we have to gain the access of victim's computer. And for that, we'll be needing a Trojan. So now let me go to the new screen to Kali Linux, so that I can we can try building the Trojan. So this is the Kali Linux screen, and over here I'll try to build the Trojan and demonstrate how it works and try to analyze it as well. So let me first discuss a bit about the Trojan. Here we'll be using the here we'll be using the MSF vnorm program, MSF vnorm. And this is a very interesting program which is being offered by Kali Linux. So this is a Kali OS, and inside this, what we'll be doing is we'll be having a payload. We'll be having a payload. So we'll be having two different Trojans. One is out one.exe, which is only having the payload, just the payload itself. And this payload will be this payload I have selected to be the Windows Windows interpreter reverse TCP. So that this payload is basically giving us a reverse shell. So what exactly a reverse shell is? Now, basically, if we say that this is the victim's computer, this is the victim's computer, and somehow our Trojan has been installed in the victim's computer. As soon as our Trojan is installed in victim's computer, the Trojan will be giving us a reverse shell. So this reverse shell is being given by TCP. So as we know that TCP is a transport layer protocol, it helps us gaining the access on the victim's computer. So basically this uh, reverse shell is coming to the attacker's computer. Now, the reverse shell is basically a request back to the IP of the attacker's computer. So it is very necessary that both the computers are in the same network, are in the same network. Because if it is not in the same network, then we won't be able to get the reverse shell. So the victim's computer will be requesting back to the same IP, giving it a reverse shell, basically giving it all the root access, giving the attacker all the root access of its computer. So that is a payload. This payload will be sent to the victim's computer. We can install it somehow with some pen drive or something, just have to run it. And this payload, so one Trojan is without encoding, the other Trojan will be developing using encoding. So encoding means we'll be basically encrypting the whole payload so that it becomes hard for any of the software to identify, like any of the antivirus software to identify whether what file it is. Basically, we'll be trying to do some obfuscation and trying to hide that we are trying to send some Trojan to the victim's computer. Let me clear all the drawings and let us try to build the Trojan. So as I said, we'll be using MSF vnom. So let me write MSF vnom, and we can see a lot of things over here about MSF vnom, and like for payload we have to write dash p for payload, like for getting the payload and all, and for list we have to dash l. So all the shortcuts and all the codes have been showed over here. So if we want to learn more, I have used this dash h, which gives all the kind of codes in it. So let me try to write the command which will be basically like basically developing the Trojan. Before that, let us try to see which encoder which we'll be using. We can use MSF vnom dash L encoder. Doing this, it just takes some time, I guess probably 20-30 seconds or more or less than that. It will be showing all the encoders. It is having a huge set of encoders, like thousands of encoders. So it has come. So these are all the set of encoders which MSF vnom is having, and it has also ranked it. Description is given: low, good, manual, low, good, normal, excellent. So it has given which encoder is good. So I have found a good encoder, which is this x86 Shikadaganai polymorphic XOR additive feedback encoder. So basically it is using XOR function. And as we have seen, this XOR function is very useful in cryptography, also in obfuscation. It just hides the file, just changes it completely. The rank is excellent. So we'll be using x86 Shikadaganai encoder, and we'll be trying to iterate this encoder a lot of times on our payload, such that our payload is completely safe. We'll try to completely safeguard it. So let me try to write the code of it. So msf vnom, so msf vnom slash p. Now we are with dash p will be trying to get our tc like our payload. So our payload is a windows based payload. Windows, it is a meterpreter. So windows meterpreter slash reverse tcp, reverse underscore tcp. Then this is the payload. Windows meterpreter reverse tcp will get us gain the reverse shell. Now in this I'll be specifying the host name, like to which IP address it should come. So for that I have to go to another a new window, a new terminal, which will, from where I can see what is my IP address. So for that I'll be doing if config, and if config, I can see my IP address is 10.0.2.15. So this is my IP address, and I'll be just making a note of it such that I can just write it when I need to write the. Okay, so I made a note of it. Now we'll again go back to our previous this one, yeah, previous a terminal window. Over here I'll be meant like giving the L host. So L host is the thing which will be basically the IP address to which it is coming back. So L host is equals to 10.0.2.15. Okay, 2.15 done. And also a port we have to mention, as it is a TCP, it is using TCP. Definitely it is a transport layer protocol. We have to mention the port. So generally 443, port number 443 is always open. It has been seen. And okay, so the port names and all has been given. Now we'll be giving the encoder. For giving the encoder, we have to write dash E, which is the command for entering the encoder. And as I told, we'll be using x86 Shikata. So S86 slash Shikata, and okay, a bit a confusing name, Shikata Ganai, and this is the encoder. And now I'll be iterating the same encoder a lot of times on my um, same payload, the meterpreter payload which I'm using. So I'll be using let us say that 200 times I am 200 times I am iterating it. So dash I is for iteration 200, and then I have to save all this in a executable file. So uh, dash F for that, saving everything in an executable file. So dash exa exe file we want, and that exe file I want it to be like named as out.2 dot out.2 out.2 dot exa. So this will be the thing. Let us try to run it. So it will take a bit of time because a lot of things it has to do. 200 times it will be iterating the same encoder, and then we'll be able to see that our out2.exe file will be matched, will be made. So as I can see that there is some um, error. So I'll just try to, okay, I guess uh, already one time I have run, so I don't have to give this L port and L host. Without that only it will work. Let us try to do it, because if I have run it already, so if it already saves the L host and L port, that's why probably it gave a error. No, okay, yeah, now it is iterating. Yes. So basically I have run it already like some time back. So it saves the L port and L host. That's why it was giving some error, because I have already made another Trojan. I'll show you. LS. Now this Trojan has been made, and you can see the payload size is 6089 bytes. Final file size is 6089 bytes. And okay, final exe file is 73802 bytes. Okay, now I'll be doing ls and I'll see I can, okay, yeah. So out.out.out1.exe is something which I already made. In that I had mentioned that l host and l port, so that's why I guess it just remember, we don't have to do it again. Once we have done so, it remembers the l host and l port. So out1.exe is there, out2.exe is there. So these are two trojans. So definitely now we'll go on for the analysis. So for analysis, we'll be first going to our virus total. This is the virus total page, and over here I'll try to upload the files one by one. First we'll try to upload the out1.exe. So choose file. So from here I can choose out1.exe and open it. So when I open it, so I can see, okay, directly it has generated the uh, MD5 hash code probably over here. And these are the suspicious, all the like different antiviruses which has identified it as a like virus or a trojan. So there are some of them which haven't even done even like detected them, and some of them which haven't given anything, so like timed out or something happened. So but there are quite a few uh, big good companies of like AVG, and we can see adware and different, I guess probably Kaspersky is also there. Exactly, Kaspersky, K7 antivirus. All these have identified this Trojan as a Trojan, and we can see trojan.crypt.gen. It has even given the names. So now this was for the out1.exe. Now the one we just made, which is out2.exe, let us try to choose that. It was encoded. So let's see that if some of the different viruses, like the antiviruses, are not able to like identify it, because this was like completely encoded. So let's see that. So it is uploading now. It is doing the analysis. Till now it has then, okay, it started detecting five of them has detected, 14 of them has detected. So let's see the final result. 51 of them has detected it. 53 antiviruses have detected it. So analysis still going on. It takes a bit of time to run the total analysis. Okay, so 54 is the score, and the previous score we have to check. So 54 is the score, and so 54 antiviruses have identified it. Let us check the previous score of the out1.exe. Let me just open it again. It will just uh, okay, so it was okay. So this is surprising result. Like 50, the out.exe, which was not encoded, it is it has been recognized with some less antivirus softwares, but the one which was encoded is like identified with more antivirus softwares. So this is something which tells us that when we are using encoding. So these days some new softwares have see like they have developed in such a way that if some new encoding has been done, then they will be like able to get it, like able to tell that maybe this can be something malicious. So this analysis concludes that thing. And now I'll directly take uh, us to the any run screen, and I have already done the analysis of out1.exe, and we can see that we have this any.run couldn't identify it as a Trojan. This is a surprising thing. That means our Trojan may be malicious, a lot malicious. But as we can see that sometimes advanced static analysis can be more beneficial. But some good results which we have got is, we can see that some of the DNS requests, connection requests have been made. Let me just zoom it a bit. Just Yes. So yeah, connections. I'll go to connections, and over here we can see that this IP address. Just I'll try to show it. IP address 10.0.2.15, which was my IP address as I showed in ifconfig. The Trojan is trying to call back. So it is trying to call back basically a reverse shell. It's trying to give me a reverse shell of the victim's computer. So basically this any dot run runs the Trojan in a real computer in a real virtual environment. So this computer tried getting back to this IP address, but it was not detected because this virtual environment was not in the same LAN network as I was. The advanced malware try to get back to some malicious websites. From there they try to connect, but as this Trojan is working under the LAN network, it didn't get a good call because this IP address is not universal. This is only for the LAN, but we can see that port number 443 was used, and IP address 10.0.2.1.15 was used for a reverse shell, or giving back a reverse IP request. And we can see the protocol which was used is TCP. So everything which we did is shown in any.run. Let me clear the drawings, and now we'll try to run the out2.exe. So new task. I'll try to upload the out2.exe, open, and run as a public task. So it loads and allocates a new environment, takes a bit of time. Now we can see that we have done with the analysis, and till now connection has not been made, and it is still running the analysis. So this is how we can do, and we can see that some application screen has been appeared on the virtual environment. So like check on something is running on the virtual environment by our uh, encoder, and we can see some DNS requests it is trying to make, and one connection request has also been made through it, through the Trojan. And yeah, this is how we can use our payload and Trojan to get back call requests. Some threats had been analyzed. So potential corporate privacy breach, and let me see that again, unknown traffic. So this is how the Trojan is attacking on us. So this was the analysis of both the Trojans and the keylogger. So basically what we can do is we can just try taking the Trojan, putting it to the victim's computer, and when we gain the access we can just directly push in our keylogger inside the victim's computer, so that we can have a whole access to the computer. We can directly push anything. We can push our keylogger, get any passwords. This is how these malicious softwares are being used. But as we can see, good things which we have got from this project is that many of the antiviruses were able to identify the Trojan, were able to identify it. So it is very unlikely that the victim's computer will be executing that, because before that only the antivirus software will be identifying the Trojan and will be destroying it. So thank you for this was my explanation. Thank you.